Alrighty, welcome back everybody. So what we're going to do today is modular math division. So to do division we have to learn a couple of things first, or remember a couple of things actually. It's a little of both. Multiplicative inverses. What's a multiplicative inverse? Multiplication inverse returns it back. Remember, the multiplicative inverse gets it back to the identity. And that depends on if we're doing multiplication or addition, which identity we're talking about. In multiplication, the identity is what number do we multiply with to keep the same identity, the same number. What do we multiply with to always stay the same? 5 times what is 5? A half times what is half? Right, 1. So 1 is the multiplicative identity. So the multiplicative inverse gets us back to 1. So in regular numbers, if we had something like 11, the multiplicative inverse would be times what to get back to 1? Well, we'd multiply by its reciprocal in that case. The reciprocal in regular numbers is the multiplicative inverse. So 5 times 1/5 would give us 1. 2/3 times 3/2 would give us 1. So all of those in regular numbers get us back to 1. What we need to do is figure out how to do that with modular numbers. And that's a little different because remember, there's no fractions in modular math. So we can't just multiply by the reciprocal. So what we have to do is we have to create a table to start with. So what we're going to do is we're going to start with mod, oh gosh, let's start with mod 11. Why not? Let's go big. Mod 11. So mod 11 has what numbers in it? Right, 0 through 10. So here, I'm going to start my table. My number's going to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Every number in my mod. Next, what we're going to do after that is we're going to write its inverse. But we don't know what it is. So, here's the thing. We have to realize that it's going back to 1. And it's with multiplication. So 0 times anything's still going to be 0. You're never going to get to 1. Can't happen with a 0 in any kind of math that I can think of. So our inverse for 0, well, there isn't one. Okay? It just isn't there. 1's easy, because it already is the inverse. Multiply it back by 1 again and you're still at 1. So 1 is always itself. Okay. Now here's where the trouble becomes. Well, 2, 3, what do you multiply a 2 by to get back to a 1 in modular 11? Well, that's where we need to come up with another table. We're going to add to this table. We're going to add to it 1s. A list of all the ways we can get to 1 with mod 11. Well, 1 is definitely a 1 already. But what's the next one? Now think of it. Remember, modular math is circular. It goes around and around. So if we start at 1 here, how do we get back to 1? How many do we have to add to it to get to 1? Right. The mod itself. If we add 11 to 1, we get 12. And 12's not in the mod, so we'd have to modify it, right? We'd have to convert it back to a mod number. And how did we do that from last lesson? We divided out the mod, and the remainder was the, well, 11 goes into 12 one time. What's the remainder? 1. So the easy way to do this is just keep adding the mod to this number. So 1 plus 11 is 12. We just figured out that's a 1. Well, if we go around again, add another 11 to it. 23. Add another 11 to it. 24. Another. 35. Another. 40. What is it? I feel like 40. Yep, 46. Nope. Wrong right there, aren't I? Good catch. Some of you caught that already, didn't you? 23, 34, 45, 56. How did I catch that? I caught that because I noticed the numbers were no longer 1 apart. Huh. So how far do we do this until? Well, really what we're going to do is we're going to do this list until we get to that number times itself. The last number in your mod times itself. What is 10 times 10? It's 100, right? I bet you this gets us to 100. Let's see what happens. So we get what? We get 67, 78, 89, 100. There it is. Okay, now why did we do that? We did that because this is a list of ones, ways that we can get back to our identity with the multiplicative inverse. So why did I stop here? Well, because the way to get to that one is that one times itself. So I'm going to go ahead and write 10 right next to itself. And guess what? The last number will always be times itself. That'll always be its inverse. So you know that's where you stop. You don't have to worry about this. Why did we do this? What are those answers? Here's how we do the rest. What number, 2 times what number of these numbers, 2 times which one of them will give us one of those? Well, do you see it? I do. 2 times 6 is 12, right there. That means that 2's multiplicative inverse is 6, because 2 times 6 is 12, and that's 1. And 6 times 2 would be 12. So every time you find one, you actually find the other, unless it's times itself, right? So what's 3? 3 times which of these numbers gives us one of those? 3 times what? Hey, it's 12 again. 3 times 4 is 12. And 4 times 3 is 12. So we get that. What about 5? 5. Look at the leftover ones. What do we have? Well, I see 7 times 8 is 56, right? So 7 times 8 and 8 times 7. Now, I'm betting 9 times 5 is one of those numbers. I'll bet you it is. Yes, it is. 5 times 9 is 45. So 5's inverse is 9. 9's inverse is 5. Okay, now we have the table of inverses, and this is what we need to do division. We have to do this process first, getting back to 1. So what did we do there? We listed all the numbers of the mod, and that's 0 to 1 less than the mod number. Then we always say 0 has no inverse, 1 is its own inverse, and the last number is its own inverse. Then we take 1 and keep adding the mod to it. Keep adding the mod until you get to this number times itself. It'll always end there if you're doing it correctly. That's one way to check yourself. So good. So now let's do some division. Okay. Well, I told you that there were no fractions in modular math, but guess what? That's how we're going to show you division. Because remember, every fraction really is division, isn't it? So let's do, since we're in mod 11, let's do 5 divided by 7. 5/7. Well, it's not 5/7 in modular math because that's not a whole number answer. So what is 5/7? We have to realize that's really 5 divided by 7, right? Now think about fractions. Remember, I've always told you that fractions are going to keep coming up, and the things we learn in fractions we keep applying in higher math. Well, we're going to deal with division of fractions because we kind of have a fraction, and that is division, right? So here's what I'm saying. Division is the same as multiplying by what? Division is the same as multiplying by what? Now, in regular math, we said that was multiplying by the reciprocal, right? Just flip it over, reciprocal. But what did we say the reciprocal was the same as earlier? Right, the reciprocal is the same as the multiplicative inverse. That's what we're doing, right? So 5 divided by 7 really is the same as 5 times 7's inverse. Okay? 7's multiplied by the inverse. Okay, well, what is 7's inverse? 8. 7's inverse is 8. So really, what we're going to do is we're going to solve 5 times 8. I know it seems weird, huh? But what is 5 times 8? You know that, right? It's 40. And 40, not in our mod. So now we have to convert it to a mod number. How do we do that? Remember what I said earlier in this one and in the previous lessons was we divide by the mod and the remainder is the solution. So we're going to take 40 divided by 11. Well, let's see. I know 4 times 11 is too much. That's 44. So it's going to be 3 times 11, 33. Subtract, and we get, of course, right? We get 7. So guess what? 5/7 actually equals 5 divided by 7 is 7. Seems odd, huh? It's a weird thing. Well, that's the idea. Let's do another one with our same mods. We have this same setup here really quickly. So let's try something like, let's just do a different color here. Let's do 2 divided by 3. Okay, well, that's the same. 2 divided by 3. 2 times 3's inverse. 2 times, what's 3's inverse? 4. And 2 times 4 is 8. So our solution here is 8 mod 11 for 2 divided by 3. And up here, I really should say 5 divided by 7 is actually equal to 7 mod 11. Good, good? Does that make some good sense, folks? Cool. We're going to do another example similar to this because what we're going to do next in the next video is modular algebra. I know, seems a little odd, but we can do that, modular algebra. And I got your popsicle joke. Are you ready for that? Let's see. What did the apple tree say to the farmer? What did the apple tree say to the farmer? Stop picking on me. Leave me alone. Stop picking on me. See you next time. Bye.